Okay, here we go. More inscribed angles. I'm going to give you two theorems first, and then I'm going to do some example problems. So, on the bottom of page 725, you got Theorem 10.8. Says, an inscribed angle of a triangle intercepts a diameter or semicircle if the angle is a right angle. An inscribed angle of a triangle intercepts a diameter or semicircle if the angle is a right angle. So here's what that looks like in a picture. If you've got a circle and let's put a diameter in this circle, a chord that goes through the center. A chord that goes through the center is a diameter. An inscribed angle of a triangle intercepts a diameter or semicircle if the angle is a right angle. That means if this inscribed angle, this red angle, do you see how it intercepts the diameter? Its vertex is on the circle, but its chords that make the sides up end on the ends of the diameter. When that is true, this is a 90-degree angle, which means that is a right triangle. The pictures that you'll get of these triangles inside these circles, they won't put the 90-degree angle in there. What you have to understand is that if an inscribed angle has, or if an inscribed angle intercepts a semicircle, this around the back of here, this arc that goes from one end of the diameter to the other end of the diameter, that's a semicircle, okay? It measures 180 degrees. And since it measures 180 degrees, the angle that's created back here is a 90-degree angle. And you're going to be given this picture in some different situations, and especially some different looks. You may get it in this look. A line or a segment going across a circle that goes through the center. It's a diameter. Alright? So you may get this alone. That blue angle is 90 degrees. This angle right here, angle A, right there, that's a 90-degree angle. It's an inscribed angle. It intercepts a diameter, so it forms a right triangle. You may get this picture. Alright, that red angle, angle B, that is a 90-degree angle. Okay? Everybody see that? All right, so let me give you one more theorem, and then we'll do some example problems that relate to both. On page 726, Theorem 10.9, if a quadrilateral that's a shape of four sides, is inscribed in a circle, then its opposite angles are supplementary. And supplementary means that they sum. How much do they sum? They sum 180. If a quadrilateral, that's a four-sided shape, is inscribed in a circle, then its opposite angles are supplementary. So what you do is you take a circle. In that circle, you take a four-sided shape, a quadrilateral. Call this quadrilateral ABCD. Now, since it's a quadrilateral and it's inscribed in a circle, that means the measure of angle A plus the measure of angle C has to equal 180. Every time, all the time. Angle A plus angle C measures 180. They're opposite of each other, they're inscribed in a circle, therefore they're supplementary. It also means that the measure of angle B plus the measure of angle D is equal to 180. The measure of angle B plus the measure of angle D, opposite angles, quadrilateral inscribed in a circle, opposite angles are supplementary. Everybody see that? Understand it? All right, let's take a look at a couple of example problems. First example problem relates to the first theorem. All right, you got a circle. It's got a diameter. And then that diameter is intercepted by an inscribed angle. So you're told that this angle up top is 4x plus 2. This angle is 9x minus 3. And we got HGF. You're asked to find the measure of angle F. The measure of angle F. When you see this picture and you see this inscribed angle, angle G, that ends at point H and it ends at F, it intercepts the diameter, so it is a right triangle. And if it's a right triangle, then 4x plus 2 plus 9x minus 3 have to add up to 90 degrees. The three angles in the triangle add up to 180, but this is already 90 of it. So the acute angles in a right triangle sum 90. So your math becomes Your 4x plus your 9x is 13x. Your positive 2 plus your negative 3 is negative 1 equals 90. So you add 1 to each side. 13x equals 91, and you divide by 13. And x equals 7. X is equal to 7, but they want the measure of angle F. So the measure of angle F is equal to 4 times 7 plus 2. 4 times 7 is 28 plus 2 is 30 degrees. There's your angle F. Everybody all right with that? There's another problem in your assignment that you need to recognize. Take a look at this circle. Here's our center. Chord going through the center is the diameter. Now, if you get this picture, and you get tick marks on the sides of this inscribed angle, and you're told that one of the angles is 4x plus 10, and you're asked to solve for x, or you're asked to find an angle measure. If these two sides, well, first of all, you've got an inscribed angle that intercepts the diameter. So this is a 90-degree angle. If that's a 90-degree angle, then the two acute angles in the triangle have to add up to 90. Well, if these sides are the same, that's an isosceles right triangle. And if two sides of a triangle are the same, then the base angles are the same. So this angle, you're not told that, but you have to know that this angle over here is also 4x plus 10. Okay? So your 4x plus 10 plus your 4x plus 10 would have to equal 90. So you got 8x plus 20 equals 90. You would subtract 20. So 8x would equal 70, and then you could divide by 8. And 70 divided by 8, 8.75. All right, a couple of examples related to the second theorem that you wrote down today. Circle with a quadrilateral inside of it. Let's say you've got a 60 and a 2x and a, let's see if that's 2x, let's say this is 2x plus 20, and we'll go down here with a 2x minus 15. If you're asked to solve for x, or if you're asked to find any of these angle measures, you got 4 angle measures here. You got A, B, C, and D. To set this problem up, opposite angles are supplementary. Opposite angles are supplementary. So if you take, let's take the 2x and the 60. 2x plus 60 has to equal how much? Supplementary. Good, 180. So in this case, you could subtract 60 from each side. And 2x would equal 120. And then you could divide by 2. And x would equal 60. Now, change these x's in this other problem to y's, please, because they won't give you x's in all the problems, in all the expressions, because then you would only have to solve one equation, and then we want you to solve two equations. Okay? So in this second example, to solve for y, you got a 2y plus 20 plus a 2y minus 15, and they have to add up to 180. So your 2y plus your 2y is 4y. Your positive 20 plus negative 15. 20 minus 15. Positive 20 and negative 15. That's a positive 5. Alright, we've added this expression to this expression, and those got to equal 180. So you can subtract 5 from each side, and your 4y equals 175, and you can divide by 4. So y would be equal to 43.75. So quadrilateral inscribed in a circle, opposite angles are supplementary. Alright, they sum 180. Anybody have any questions on any of that information? Your assignment for today is on page 727 again. Problems 8 through 10. And then over on the next page, 23 through 30. Please do the assignment on a separate sheet of paper, so if I collect it, you don't. You still got your notes. And guys, you have to show all your work. If you turn in your assignment and all you've done is drawn some circles and drawn some inscribed angles and then listed an answer, I can't give you credit for that, because I give you the answers at the beginning of class. So you have to show me how you got your answer. Okay? Very good.